Hi there. For this video, we'll be discussing exponential equations. So this is another type of equation. So before we can dive into our examples, what are exponential equations? Well, let's first start with this form. If we have a raised to x, we know that in exponents, our knowledge on exponents, this one is the base, and this one out here is the exponent. For exponential equations, the exponent part here is our variable. So that is how it works. Since in polynomial equations, what we have is like x squared, wherein in this exponential form, the base is the variable out here, and the exponent is the typical exponent. But note that the exponent out here is not limited to just a variable. It can also be an expression such as b raised to x plus 2 or c raised to x squared plus 4x plus 4. That. So we will be dealing with these types of expressions in our examples. So let's go on to our first example. Just a basic one. If we have 5 raised to x equals 25. So we are solving for the value of x. Now intuitively, we can inspect that x must be 2. Since we know that 5 squared is equal to 25. And this one is indeed true. To formally show the solution, what we do is we write here 5x, and on the right side, we express 25 as 5 squared. And since we have the same base, then that means that the exponents out here must be also same. So we have x must be equal to 2. And indeed, x is equal to 2. And as you can observe, this will be our main strategy here. Our goal will be to convert the bases to be the same. In this case, we have converted it to be both 5. Since when we are able to do this, we can immediately imply that the exponents must be equal or the same. So take note of that, as we will be diving into now more complex examples. Let's have 2y squared minus 1 equals 8. Okay, for this one, note that since we still don't have the same base, we can actually express 8 as, so it's right here, 2y squared minus 1 equals 8 is actually equal to 2 cubed. And now we have the same base. So we can imply that the exponents must be equal. So we have y squared minus 1 equals 3. And what do we have here? We have a quadratic equation. So we can move 3 to the left side here to obtain y squared minus 4 equals 0. And by factoring of the difference of 2 squares, this one is simply y minus 2 times y plus 2 equals 0. So this implies that either this is equal to 0 or this is equal to 0. that would give us y is equal to 2 for this case out here, and y is equal to negative 2 for this case out here. And these two are our solutions. But to verify, we've got 2 raised to 2 squared minus 1. That will be 2 raised to 4 minus 1, and this will be 2 cubed, or simply 8. For negative 2, we've got 2 raised to negative 2 squared minus 1. That will be 2 raised to 4 minus 1, and this is 2 cubed and also 8. So indeed, these values of y are correct, and you can conclude that they are indeed the solutions to this exponential equation. Let's go on to our third example. Let's have 4 raised to 3z 3z minus 5, and this one is equal to 0.125 raised to z minus 3. Now, might seem terrifying at first since we have a decimal. We have a decimal out here. But note that we can always express a decimal into its fraction form. Indeed, 0.25 is actually equal to 1 over 8 in fractions. So how did we obtain that? If we have 0.125, we know that we can have this denominator as 1, since it's just the same as 0.125. And we can add the decimal point here and some zeros. And by our knowledge on how to convert a decimal to fraction, we simply move this decimal point the same number of times in the numerator and in the denominator. So we obtain here 125 over 1000, and when we simplify this fraction, we obtain 1 over 8. So with this in mind, we can rewrite this as 1 over 8. And now it might seem still a bit hard, but it's now easier than the first one. Since, note that 1 over 8, we can write that as, it's right here, 4 raised to 3z minus 5 equals 1 over 8 can be written as 8 raised to negative 1 raised to z minus 3. And by laws of exponents, we can simply multiply this to obtain negative 1 times, so we have negative 1 times z minus 3. That will give us negative z plus 3. And now, from here, note that 4 is equal to 2 squared and 8 is equal to 2 cubed. So with this in mind, we can write this one as 2 raised to 2 raised to 3z minus 5, and this one is equal to, on the right, we've got 2 cubed raised to negative z plus 3. And by laws of exponents, again, we simply multiply these values out here to obtain, on the left side, we've got 2 raised to 2 times 3z minus 5 is 6z minus 10, and on the right side, we've got 2 raised to 3 times negative z plus 3 is negative 3z plus 9. And from here, we already have a similar base. So let's clear out some space out here. So we can now note that since the bases are similar, then the exponents must be the same as well. So we've got 6z minus 10 equals negative 3z plus 9, and this is just a linear equation. So move this negative 3 to the left side and move this negative 10 to the right side to obtain 9z equals 10 plus 9 is 19. Then we divide 9 both sides to finally obtain z equals 19 over 9. You can verify that by applying this value of z to our original equation. So to make it harder, let's write this as 0.125. You can apply this, so maybe you can use a calculator this time and apply this value of z to our original equation, and you'll see that applying it on the left is equal to applying it on the right out here. So that is the answer for this equation. Now, before I end this, here is one last example, which is kind of tricky at first, but is useful when you learn how to solve this one. So let's have 9 raised to x minus 7 times 3 raised to x equals 3 raised to x plus 9. So this is quite a new form from what we had been solving a while ago, but let's try to slowly form this one. So first, let's move this 2 to the left. So we'll have 9 raised to x minus 7 times 3x minus 3x minus 9 equals 0. And from here, note that if we treat this as a variable, say this is y, then we'll simply have negative 7y minus y. So this is simply 9x minus 8 times 3x, 3 raised to x minus 9 equals 0. Now, what do we have to do? Well, note that 9 out here can be written as 3 squared. So we'll have here 3 squared raised to x minus 8 times 3 raised to x minus 9 equals 0. And then, I hope you're kind of noticing it already, by loss of exponents, we can actually interchange this one. So we'll have here 3 raised to x squared minus 8, and let's use parentheses here, 3 raised to x minus 9 equals 0. And what form do we have here? It looks like a quadratic equation, since we have a degree of 2 here, and degree of 1 here, and degree of none here, and this one. So, to make it more like a quadratic equation, we can let u be equal to 3 raised to x. So this will become u squared minus 8u minus 9 equals 0. And now we know how to factor this. This simply factors to u minus 9 and u plus 1. And from here, we know that either this is equal to 0 or either this is equal to 0. So the first will give us u equals 9 and the second will give us u equals -1. And what do we do next? Well, recall that up here, u is equal to 3 raised to x. So we simply replace back u out here with let's use yellow, with 3 raised to x. So let's try to clear out some space first, since I'll be exploring these two cases out here. So let's start first with this one. So if you ask yourself, what value of x will make this one out here be true? Unfortunately, the answer is none. Since if we have 3 raised to 2, so 2 is positive, the outcome is positive. If we have 3 raised to -2, this is simply 1 over 3 squared. So the outcome is still positive. And in fact, if we have a fraction out here, this is simply square root of 3, and the outcome is still positive. So there are actually no values that would make this 3 raised to x be a negative value. Therefore, for this case, we say that there are no solution. So we only focus on this first case, and this one is easier to solve since we simply have 3 raised to x equals 3 squared, and we've got x must be equal to 2. So that is the answer to our exponential equation. So as you can see, there are some elements of quadratic there are some elements of our idea on quadratic equations out here, since it involved substitution to make it a quadratic equation. Now, before I formally end this with some exercises, here is a good question to think about. How do we solve if we have, say, 3x equals 5? Since as you can see, the basis out here is different, but there is a solution to this one, unlike the example that we had a while ago, which is 3 raised to x equals -1, since 5 is positive. So how do we solve this one? For now, we still can't solve this one, but we will be needing a certain concept called logarithms. So I hope I spelled that one right. So we will be needing logarithms. So essentially, logarithms are like the inverse of exponential, and we'll be talking more about that in the next video. So now, as an exercise, here are 2 exercises that you can work on. So first we have 169 raised to y plus 1 equals 13 raised to y squared minus 4x plus 8. And then, so this is for the first example. For the second example, we have 8 times 4 raised to c minus 30 times 2 raised to c, and this one is equal to 3 times 2c minus 4. So yeah, quite a lengthy problem. But basically, in this first one, this one is more straightforward. It will just involve some knowledge on solving quadratic equations. And for this one, we'll be applying the substitution method that we had in the last example for this video. So that's it. I hope you enjoyed this one. So it's also quite a lengthy video, but I'll make sure to put in the timestamps below so you can skip through the examples that we had in this. So yeah, feel free to comment down below your answers and solutions to these exercises. So that's it, and that's all for this video.